Hi, good morning. This is Trina here to discuss about quality of boiler fed water. And if you have any doubt, you can communicate either through my mobile number or through my email ID. And the most important part is given here, that is my course page. So all the study materials along with probable questions and also the semester questions and the solved problems are given here. So you can access it anytime, anywhere. And first of all, you have to join with my subject code that is given here, that is TONZBBRO. The subject name, that is the environmental science subject code, that is MC301 for odd semester and MC401 for even semester. This course is for undergraduate BTech students and the streams are CSE, IT, Civil, Mechanical and BM. And the course objectives are: the students will be able to understand the natural environment and its relationship with human activities. They will be able to apply the fundamental knowledge of science and engineering to assess environmental and health risk. They will be able to understand environmental laws and regulation to develop guidelines and procedures for health and safety issues. They also will be able to solve the scientific problem solving related to air, water, noise, and land pollution. So we can hope that the future generation, the future citizen will be enough responsible to protect our Mother Earth. They will acquire skills for scientific problem solving related to air, water, noise, and land pollution. So here the entire syllabus is given. First the general part, then the module 2, that is the air pollution, and the module 3, that is the water pollution. And today I'm going to tell about the quality of boiler fed water. This is the quality of boiler fed water. So what should be the quality in the boiler? What we use in the boiler, and what should be its TDS, what should be the dissolved oxygen, what should be the hardness, and what should be the chloride. So next, the topic is like the other chapters are like noise pollution, land pollution, and the reference or books are given here. So you can avail these books from the library. So here the entire lesson plan given, that means per lecture which topics will be covered, that is given here. So now, what is the boiler? So a boiler is a closed vessel in which fluid, generally we use the water, is heated. The fluid does not necessarily boil. The heated or vaporized fluid exits the boiler for use of various processes or heating application, including water heating, central heating, boiler-based power generation, cooking, and sanitation. So here you can see the structure of boiler. Here you can see the structure. Here you can see the structure. Next, The boiler feed water. Boiler feed water is an essential part of boiler operations. The feed water is put into the steam drum from a feed pump. So you can see here that is the feed water, and it can be drum from a feed pump. In the steam drum, the feed water is then turned into the steam from the heat. So here the heat is provided and this water will be converted into steam. After the steam is used, it is then dumped to the main condenser. From the condenser, it is then pumped to the deaerated feed tank. From this tank, it then goes back to the steam drum to complete its cycle. The feed water is never open to the atmosphere. So this cycle is known as a closed system or Rankine cycle. So you can understand that the feed water which is used in the boiler, that is very much important. The quality of this water is very much important. And in my last lecture, you have learned different water quality parameters like physical water quality parameters, chemical water quality parameters. So what should be the water standard, the quality of the water which we will use in the boiler? That is very much important. So first, I will tell about the hardness of water. The hard water can be used in the boiler or not. So the hard water, what do you mean by hard water? It is very hard, very difficult. Okay, not like that. If the water consumes more amount of soap, if it does not form lather easily, that is called hard water. So why we get the hard water? That means what is the cause of the hardness of water? Why it will take more time to formation of the lather? So you can see here that is the soft water or hard water. There are two types. The hardness is lower, that is called the soft water. Okay, so water which obtained from rain, that is the soft water, that does not contain much amount of salts, and the hard water which contains the salt of calcium and magnesium and also the salt of iron, that is called hard water. And this hardness, so you understand the hardness, why it is the hard water, or why we tell that is that contains the hardness. So if it contains the salt of calcium and magnesium, then it is called the hard water. So it may be different types of salt. It may be like, say, calcium sulfate, it may be calcium bicarbonate, it may be like magnesium chloride. So it may be different types of salts. So the presence of the salt of calcium, magnesium, and also the iron, that is called hardness. So if it is like, say, when we say it is the soft water, so if the hardness is less than 50 milligram per liter, it is the soft water. The moderately hard water, that is 50 to 150 milligram per liter. Hard water, that is the 150 to 300 milligram per liter. And very hard water, that is 300 milligram per DL. So hard water is not suitable for industrial purpose. And why it is not suitable for boiler, I will tell gradually. So what are the types of hardness? So hardness, it is of two types: temporary hardness, permanent hardness. Temporary hardness which causes bicarbonate ions, that means like calcium bicarbonate or magnesium bicarbonate, that is called temporary hardness. But if it is like, say, it contains sulfate or chloride, then it is called permanent hardness. Like magnesium chloride, like calcium chloride, calcium sulfate, magnesium sulfate. So this is called the permanent hardness. So you have learned very well what is the temporary hardness and what is permanent hardness. Now, what is the disadvantages of hardness? So the disadvantages of hardness, like wastage of soap, I told that it is the soap consuming capacity. Hardness means the soap consuming capacity. How much it will consume? The soap, it will consume more. That means the hardness is higher. So it is the soap consuming capacity. So if we use the hard water for washing purpose, we require more amount of soap and it does not form easily leather. And wastage of fuel, formation of scales on metallic boilers. So we can understand that if it is a hard water or not. So there are some sign. That means, like, say, few examples, like clothes look dull and feel rough, ugly stains on white porcelain, and scale built up on facets. So these are the signs that we can understand that we are using the hard water. So we can determine the hardness in our chemistry lab. So how we can do this? If we want to calculate for our like tap water, say we want to calculate for tap water, so we have to take 50 ml of tap water in a conical flask, then add 1 ml of buffer and a pinch of EBT indicator. It is the EBT indicator. Then the solution color will be red, and in the burette we have to take the EDTA. If we do the titration, then we get the color that is blue. And from the burette reading, we can do the calculation that in terms of calcium carbonate, that is the determination of total hardness. And then we also determine the calcium hardness, like to determine calcium hardness, first we have to remove the magnesium. So for this reason, we have to add 3 molar of NaOH. Then the precipitate, we get the precipitate of magnesium hydroxide and it will be removed. After that, we use the Calcon indicator and we do the same way the titration with EDTA and we get the result. So the removal of temporary hardness, it is very easy process. We can do by simple boiling. If we boil the calcium bicarbonate, it will be converted into calcium carbonate and H2O, CO2. If we boil the magnesium bicarbonate, then we get the magnesium carbonate, H2O and CO2. So we get the precipitate of calcium carbonate and magnesium carbonate. In this way, the temporary hardness can be removed very easily, but the permanent hardness cannot remove so easily. So there are different procedures, like say Clark methods, like say soda lime process, and also the ion exchange methods, Calgon process, using geolite or permutive process. So there are lots of procedures. And now our main concern is that the hard water can be used for boiler or not. Of course, we cannot use the hard water in the boiler. So what problem we will face if we use the hard water in the boiler? So there are lots of problems. Number one, that is scale and sludge formation. Number two, priming and foaming. Number three, boiler corrosion. Number four, caustic embrittlement. So one by one, I am going to describe. So first is scale and sludge formation. So also like if you use the hard water in your home, in the bucket you can notice that there is a scale will be formed. So it is basically due to the precipitation takes place due to the precipitation of different salts, like say magnesium carbonate, magnesium chloride, calcium chloride, magnesium sulfate, etc. And when it like react with the water, we get different salts. So if the precipitation takes place in the form of loose and slimy precipitate, that is called sludge. So that is the initial level. And if the precipitated matter forms a hard adhering crust, so that is called this one, the adhering crust, that on the inner wall of the boiler, it is called scale. And if it is the loose slimy precipitate, that is called sludge. Now here you can see this picture, then you can understand that what is sludge and what are the disadvantages. So what are the disadvantages? The sludge, basically first you look at the picture, then I will tell the disadvantages. So here you can see the layer of the different salts, that is called sludge. And it is the sludge versus like a scale. So initially you are getting the sludge, that is the slimy substances, but when it becomes very rigid, that is called scale. Now, what is the disadvantages? So sludges are poor conductor of heat. You can understand that if there is a layer of any other thing, and it is the bad conductor. If it is good, it would be the good conductor, then there was no problem. But as it is the bad conductor, so heat transfer efficiency reduced. And if sludges form along with scales, then former gets entrapped in the latter and both get deposited in the as scales. So excessive sludge formation disturbs the working of the boiler. It settles in the regions of poor water circulation, such as pipe connection, plug opening, gauge glass connection, thereby causing oven choking of the pipes. So these are the problem with the the sludge and for the formation of sludge and scale. So there are lots of procedures for the prevention of sludge. Basically, these are the prevention of, that means conversion of the hard water into the soft water. So what we can do, that we can use the softened water. So there are lots of procedure to soften the water. First, I told you the temporary hardness can be removed by simple boiling. So decomposition of calcium bicarbonate and deposition of calcium sulfate. That is the disadvantages of scale formation I told you. That is the wastage of fuel. So fuel will be wasted because the heat transfer efficiency will be less. Scales will have the low thermal conductivity, so the rate of heat transfer from boiler to inside water is generally decreased. In order to provide a steady supply of heat to water. And the thickness of scale, so versus the wastage of fuel is given here. If the thickness like say 12 millimeter, then the wastage of fuel will be 150%. So huge wastage. And other effect like lowering of boiler safety. So boiler safety will be lower. Basically, if the sludge formed, then the crack is created. And through this crack, if water passes, then suddenly it will be vaporized. and it will create very high temperature suddenly and high pressure, so boiler may break, may burst. So that is very dangerous. So decrease the efficiency, danger of explosion. So what I told that if the thick scales crack due to uneven expansion, the water comes suddenly in contact with overheated iron plates. This causes formation of a large amount of steam suddenly. So sudden high pressure is developed, which may even cause explosion of the boiler. So how the scale can be removed? If we should not use the hard water, but if we use the hard water, then already if the scale is formed, then how we can remove? So with the help of scraper or piece of wood or wire brush, if they are loosely adhering, or by giving thermal shocks, or by dissolving them by adding them in chemicals. So there are different procedure so that we can remove the scales. And prevention of scale formation, it is the main part is softening of water. That means we should not use the hard water before using the water in the boiler. We have to soften the water. We have to determine that which we can do in our chemistry lab, that how much hardness it contains, and accordingly we can apply the softening procedures. So there are lots of softening process: carbonate conditioning, calgon conditioning, etc., electrical conditioning, radioactive conditioning, complex metric method. Okay, next problem is caustic embrittlement. So caustic embrittlement is a type of boiler corrosion caused by using highly alkaline water in the boiler during softening process. So there is a softening process named lime soda process. So there we use soda. Soda is the sodium carbonate, is usually present in the proportion in the softened water. So if we use the excess amount of soda, then soda will remain in the water. Now this sodium carbonate will react with water and NaOH will be formed. And this NaOH makes the boiler water basic. And the NaOH containing water flows into minute hair cracks, always present in the inner side of boiler by capillary action. So here water evaporates and the dissolved caustic soda concentration increases progressively. This caustic soda attacks the surrounding area, and this is called the caustic embrittlement. So next is, and how we can avoid the caustic embrittlement, like using sodium phosphate as softening agent. That means instead of soda, we can use any other reagent for the softening purpose. Boiler corrosion. So what is boiler corrosion? So if like dissolved oxygen present in the water, then corrosion will be higher. So there is the reaction will take place, iron plus water plus oxygen, then we get ferric hydroxide. And you know very well that that is a rusting of iron. So the metal body, the boiler is made of iron. Then if oxygen is present, there water too must be present, and if the oxygen is present, then the chances of corrosion will be higher. So dissolved oxygen also take an important role for the boiler corrosion. And not only the dissolved oxygen, also other gases like CO2 also take place for the corrosion. And how we can remove the oxygen? So we can remove by mechanical de-aeration. It is the water spraying in a perforated plate-fitted tower, heated from sides and connected to vacuum pump. So high temperature, low pressure and large exposed surface reduces the dissolved oxygen in water. So before using water in the boiler, we have to do the de-aeration. That means removal of oxygen. So dissolved carbon dioxide also may causes the corrosion, and like acids from dissolved salts that also make corrosion, because you know that the acids make the corrode the metal. Priming and foaming. So when boiler is steaming rapidly, some particles of liquid water are carried along with the steam. So this process of wet steam formation is called priming. So priming can be caused by the dissolved oxygen, high steam velocities, sudden boiling, improper boiler design, sudden increase in steam production rate, etc. And foaming is the production of persistent foam or bubbles in boiler, which do not break easily. Foaming is due to presence of substances like oils. Priming and foaming usually occur together, and they are objectionable. What is the problem with this? Because dissolved salts in boiler's water are carried by the wet steam to superheater and turbine blades, where they get deposited as water evaporators. This deposit reduces their efficiency. And number two, the dissolved salts may enter the parts of other machinery where steam is being used, thereby decreasing the life of the machinery. So it reduces efficiency. If this is like priming, foaming takes place, then the life of the boiler also will be reduced. So priming can be avoided by fitting mechanical steam purifiers, avoiding rapid changing steaming rate, maintaining low water levels in boiler. So basically we have to remove for which the priming is taking place. And most important part is we have to use the softened water. That means we have, before using the water, we have to remove all the impurities present in the water. Foaming can be avoided by adding anti-foaming chemicals like castor oil, or like removing oil from boiler water by adding compounds like sodium aluminates. So the another parameter like say chloride ion. Chloride ion is one of the water quality parameter you have learned in the water quality parameter. So if like chloride ion present in the water, so what will be the problem? It will again form the HCl. So the reactions are given here. It will form HCl, the chloride ion will form HCl, and you know the acid, the HCl, will corrode the metal body of the boiler. So it causes generation of also scale formation. The total dissolved solids. So I have already mentioned the total dissolved solids, that is equal to the total solids. Basically total solids is equal to sum of the TDS, total dissolved solids, plus total suspended solid. So by the presence of this, you have seen, I have discussed the earlier that the boiler has different problems, like say carryover of solid is a dangerous issue, as it can lead to steam using machineries such as high-speed turbines. So any type of impurities will create the problem. It will causes like foaming, priming, etc. So whilst foaming can be caused by high level of suspended solids, high alkalinity, and contamination by oils and fats, the most common cause of carryover is a high total dissolved solid TDS level. So we have to take the careful control for TDS. So before we have to measure the TDS value and we have to remove the different impurities. The total dissolved solids like the chlorine content, like the hardness, all these things we have to remove. So dissolved oxygen also enhance the corrosion. Basically that creates the galvanic corrosion, and in the galvanic corrosion, that means one part is anodic part, another part is cathodic part. So these two parts is created, and the metal body, the iron, that is corroded. So the dissolved oxygen plays an important role for metal corrosion. So now, what is the important part? I have told you that we have to, before using the water in the boiler, we have to do proper analyze. We have to analyze the water. That means what is the amount of hardness present in the water, or how much chloride ion present in the water. Few parts can be done in the chemistry lab, like hardness, like say chloride ion content, all these things can be done. And dissolved oxygen also we can measure in the chemistry lab. So this dissolved oxygen, how much present in the water, and like TDS value, all these things we have to measure. Then we have to do the removal of these parameters. Then only we can use in the boiler. Then there is the boiler may burst, or this type of hazards will not take place. Okay, now I have some questions, very easy type of MCQ questions, like hardness of water due to the presence of which ions. So you have learned, it is very easy question, like calcium, magnesium, iron. So it will be all of this. So what will be the answer? It will be all of this. Temporary hardness in water may be caused due to, it is due to bicarbonate ion, I told, so it will be calcium bicarbonate. Permanent hardness may be due to the presence of calcium sulfate, calcium chloride, magnesium chloride, all. So all of this, because permanent hardness takes place due to the chloride ion, sulfate ion of calcium and magnesium. Alkali substance in the water include hydroxide, carbonate, bicarbonate. So all of this. So next, the short answer type question. What is hard water? What are the causes of hardness? So you can tell that what is hard water, which contains the salts of calcium, magnesium, and iron. And what are the causes of hardness? That is the similar answer you have to give, like bicarbonate, bicarbonate, sulfate, chloride, salts of calcium, magnesium, iron causes hardness. And what is the cause of temporary hardness? So that is the bicarbonate, and how it can be removed? By simple boiling. So not only for the temporary hardness, you have to know the softening process that I have told you, like different process, ion exchange process, like say using resin, permuted process, Calgon process. So all this process or soda lime process can be used to remove the permanent hardness. And why the hard water cannot be used in the boiler? That is the most important part of this lecture. That why we cannot use, because I have already explained. So I am summarizing the main points. That number one, due to the scale formation, sludge formation, the boiler efficiency, the heat transfer efficiency will be decreased, and ultimately it may burst also because there may be the crack in the scale due to the uneven expansion, and ultimately the boiler may burst. So this type of hazard can take place if we don't take the precaution. And not only scale and sludge formation, there are other parts like the corrosion of the boiler, caustic embrittlement, and priming, foaming. So all these things already discussed with the reactions. So when you will discuss, you must give the reactions also and explain properly. And if you can give the figure also. So what will be the characteristics of boiler feed water? It is very important. That means that you have to discuss about the different parameters, like say the TDS value, chloride ion, and the presence of dissolved oxygen that should be or should not be, and how much it is tolerable. And for hardness also, that it should be used the soft water. So these parts you have to discuss. How presence of hardness, TDS, chloride ion, dissolved oxygen in water affect boiler. So it is a similar question, just the parameters are mentioned. So one by one you have to discuss how TDS will be harmful. If the presence of TDS is very high, then what harm will take place? If the chloride ion is very high, then how it will corrode. You have to give the reaction, how it will form the HCl, and then it will corrode the metal boiler material. And how dissolved oxygen, the presence of dissolved oxygen will enhance the corrosion. So this part also you have to give the reaction and explain. So I hope that you have understood all these things. If you have any doubt, don't hesitate to communicate with me. Then now I am ending the session, and go through all my study material and submit the assignment. Thank you.